welcome to the first Go Northwest. It's exciting to be here. A little talk on modern data science and Go, or at least coming from a very strong software engineering background, what modern means to me. This talk really came out of this weird phenomenon that I saw in the Go community where once you start using Go, it's extremely hard to use any other language for any other project. I mean, the static typing, the amazing concurrency, and at the end of the day, it's just fun to program Go. We all know that, obviously, Go conference. But this led me into my other passion, which is data science, and something I was doing a lot of research in, and it was just, you can build a model to do things we thought were never possible before, to make predictions on things we just never thought we could do. The problem is anybody who does data science knows Python is a major part of that. And it's great. I mean, you can do whatever you want, and that's fun and stuff, until you want to start deploying those things, and you want to start having a reliable model that you know is going to work. And with a container that's base image is around 500 megabytes, it gets very difficult to do these kind of things. And so that's where Go comes in and takes over everything. It's amazing. I mean, static typing, when I can build a model, I know it's going to work how I want to, most times. But we'll get to that. So, close the mic. Okay. So just before we get too far into this, the slides, the code, all these examples will be on my GitHub. I'll post it on Twitter and stuff like that. So don't worry about getting too deep into that. First thing, you can't have modern without there being something in the past or something, what are we doing now? So let's take a look at a lot of the modern, or the current data science flows that we have. So you're a data scientist, you come in, you're excited, you're a software engineer, you have your data, you start cleaning it, do your feature extraction, all that fun stuff. You build your model, you're extremely excited, you work really hard on it, it's amazing accuracy, you can do these amazing things, and you're done. You're excited. You can just relax and enjoy all the great rewards that come from that. The problem is, as we all know, that's not where it stops. We have to deploy it. Until it's actually touching the user, until it's making that business impact, it's not worth anything to us. And so that's where we need to start looking at, how do we do that as deployments? How do we manage the upgrades? How do we do that? And that's where, like I said before, Python isn't exactly the best case for that. Anybody who's done installations on VMs or even containerization, it doesn't go super smoothly. And even once you get it deployed, upgrading is also not a very fun event. So here, for at least this talk, we're going to focus on three main things for what we want in modern. Number one is we want to be able to focus on our application. This goes with containers a lot, but I want to build my model or my training or my feature extraction or whatever I need, and I want to be able to containerize that and not worry about how do I scale my data? Do I manage sharding? Do I do all of that? Because it gets very repetitive to do that. And if I have a container that manages sharding, what if I don't need sharding for my data? What if I do? It makes it very difficult to scale out these instances. Number two is reproducibility. Any software engineer knows you wouldn't start a project without Git or some version control. It just doesn't make sense. Where data, though, this very delicate thing that we used long periods of time to extract, it's a very common practice to copy databases and do this. And that's becoming to a point where it's crazy. And also, with another important thing is given a result, I want to be able to see what model was used to train that result. Now, what data was used to train the model? How do I know this entire flow for either if I'm trying to roll back from a bad model, or more recent years with GDPR, it's becoming legal. You have to know your data and how it flows through your model and how this works. And finally, just manageable deployment cycles. How do we have these great models and these great predictions, but we can't upgrade them? How do we build these pipelines and go through? If I want to run new training data, do I have to really go through the entire process again? Or can I automate that a lot? And Go community is based in this automation and containerization. So first we're going to look at today is some basics of data science in Go. It's hard to have a data science talk in Go without actually looking at some of the libraries and some of the things like that. Then we're going to go a little bit into data versioning and how some new open source technologies can really help us take advantage of that. And finally, do a little example of deploying one of those pipelines and see how we can take advantage of those. So cool, basics of data science. Number one, I'm going to try to make this not just Python this and then how do we convert it, but like I said, if anybody's done data science, you know it's very heavy Python. So our data set we're going to use, here's a pretty picture. It's just some cereal. Here's a not quite as pretty picture. It's just has the nutritional breakdown, so calories and all that, and then an overall rating for that cereal. So we're going to use that, maybe some predictions. And first thing is we want to understand our data. So we want to parse the CSV or the JSON or the databases. So anybody coming from Python, this is all very similar to pandas, but Go has a library called DataFrame. And this allows us to do subsetting. We can extract our data for training and testing or anything we want with that. And in this case, we're going to use a function called describe. So very simple. We read in our file just like we would any other time, parse it with the library, and send the describe. So output for this would be, gives us a little idea of what our columns look like. So we have mean, standard deviation, percentiles. We have a little bit of base idea, at least for continuous data, of what we're looking at. So for here, you can see an example of the fibers and nutrition. But this doesn't give us a super good idea on it. Let's get a little more visual, so the plotting side. So GoNum is a really cool section of libraries for statistics, matrices, very similar to NumPy, coming from Python. It also has plotting, so a lot like matplotlib. And let's take a little example. Here's that. We'll just look through the example here. Very simple setup. We read in, just like before, the data frame. Here we're trying to do, let's look at the correlation. So we're going to do a scatter plot. We pull out our rating file, or our rating column. We just create a plot. We can add those points that we just created to the plot, just the title, stuff like that. We have, here we're creating a scatter plot, some other sure stuff. You just add it, and then we save the file. So let's see what that looks like. That's pretty small. So we can just go run scatter. Not super exciting, get the output. So here, just we can see a little bit, like, so calories and ratings, we see a negative correlation a little bit there. We see not a lot of correlation there. So this gives us a little idea. We can go much deeper into any kind of plotting with that. So histograms for distributions and stuff like that. But, so cool. Now let's talk about actually building models. So say we did the data cleaning, we went through all of that. Let's look at actually building those models. So Go has, just like scikit-learn from Python, there's GoLearn, so it has a lot of the base models, decision trees, stuff like that. There's bindings for TensorFlow, so anybody coming from neural nets. There's also tons of other amazing libraries in neural nets and Go. Today we're going to look at some linear regression, really simple model. So anybody not familiar with linear regression, all it is here we're trying to predict rating from our independent variable here, which is sugar. So given sugar, here's some training data. And what we want to do is create a line through it so we can now train our data, and given sugar, how do we relate that to rating? So everybody knows from high school algebra, y equals mx plus b, the line. Y equals your slope plus or times the sugar, in this case, plus your intercept. And this is just the what the trained model for that line is, not really important there. So there's a really good package in Go called from Sajari, a regression library. It handles linear regression. You can do single variate, so in this case, sugar to predict rating, or multivariate, so sugar, calories, predict rating. Really simple setup. We just set the variable we're trying to predict, in this case, ratings. We can add sugar, what variables we want. We just parse the data we're looking for into the floats, pass it to our model, and really simple commands. We can run it to actually do the training to find that. We can predict directly off of that model, or what we're going to take advantage of, and what I enjoy doing the most, is pull that formula out and output it, eventually into a data repository. And this is going back with that trend we're going to start seeing is, I want to track everything in data repositories, a lot like Git, to version it. So now I'll know the container calls this model, and I can version that and add that through my pipeline. So cool, this is just a really simple walkthrough of some libraries. There's a ton more. Daniel Whitenack has a really good book on machine learning Go, and there's a lot of resources with that. I'll post those Twitter, and this will be on there as well for machine learning and just in general. But now let's get a little bit more interesting stuff. When we're talking about modern, what are we looking at? And so data versioning. We talked a little bit about that before. It's just, think of it like Git, where I can make branches, commit changes. This is extremely important in collaboration. Trying to manage data and who's accessing that data and how they change it. If I want to be able to branch out and merge that data back together, it becomes very strenuous over time, especially if you're talking large teams, large projects, and seeing what happened. And like I said, the other extremely important is called data provenance, or that idea that I have a result. How do I understand how I got that result? What model did I use? What image did I use to actually do the training of that model and understand my pipeline throughout this whole thing? So that's something we'll see in the demo of kind of going through that. And so to take advantage of that, there's a really cool open source project called Pachyderm. It's written completely in Go, and it takes advantage of Kubernetes. So anybody who doesn't know Kubernetes, it's a container orchestration system. It essentially lets you treat an entire cluster or one computer, multiple computers, as a single entity that I can throw containers at, create replicas. It manages a lot of that. It's a really good project there. But Pachyderm itself is a data management, so that's where we see the data repositories, the versioning, that kind of stuff. as well as data pipelines. So it allows us to create these declarative pipelines to run through our entire project. And we'll get to that a little bit more when we actually start doing the demo. But so looking at those pipelines I was talking about, coming from a Kubernetes background, anybody who know, you write these deployment specs, they're very declarative. It's really nice because I can version control those. So same with these. In the pipeline, I can set version control, the same review processes to build out these data science pipelines from pulling the data in, extracting those features, figuring out exactly how I want to train my model, and then easily deploy those. So Pachyderm uses these JSON files. So in this case, pretty straightforward. We have our name of the pipeline, in this case model, so we're actually training the model. We have a transform section. This is where all the magic actually happens. So you say what container you want. You can give it a command. So anybody from Docker run looks a lot like that. Now this is really powerful because it allows me to version the container and understand those exactly what processes are going forward. And finally, we have input. Now this is really cool because it's how do I expose our input or those data to that container, the repository. This goes back to that section of focusing on the application. My model, my machine learning algorithm shouldn't care how the data comes in or how much data is coming in. And this allows me to, I can have multiple replicas of this. So for feature extraction, this is extremely important. Instead of running my script or having that for multiple hours, I can replicate this multiple times and then just shard that data into each container and then bring it back together at the end. And so Pachyderm uses, to do this, it uses something called Pachyderm PFS, or Pachyderm file system, that allows us to actually mount that volume into the container. And then finally, if anything you write to /pfs/out, the output, it will send it to a data repository to go, like I said, with that trend to continue things forward. So here you see a very common pipeline process. This is a simple pipeline we're going to set up today. We have two input repositories. So first is our training data. We can, once again, version, commit, do everything we want with that, the feature extraction. That's pulled into a container that's going to train our model. We saw the regression, and it's going to output that model into a repository to track. We have another where the user's input are what are we actually trying to predict. In this case, we're going to give it calories and sugar, and it's going to predict the rating. And then it's pulled into a container that also pulls in that model to output the predictions. And so you see the dependency line here, we can start adding things to it, and it will just flow through the model, that we can track every stage of this, all the data going through there. So let's take a look at the containers we're going to use. So here I just have a container to train. So I have flags, just where am I pulling my data from, and where do I want to put that data at the end. In this case, training, so I want to pull in my training data and output the model.json that we're going to store. And then I read in my CSV training data, I parse it, and then you can see I build that regression model just like before. The only difference here, instead of the single, just sugar, we're going to use two variables, multivariate. I loop through, add my training data, parse it into floats. I run my model to actually train it, and then I add it to a structure that I'm going to output the JSON, that model.json file we're going to see later that we can then track, which is where it gets important. So there I just have a Docker file to make that, so we'll go in there. And that's going to build, push, do all that. So our image is coming out to be like 12 megabytes versus that probably gigabytes we're looking at for Python once you get all the libraries set up. And then for the prediction, I have very similar. This time, though, I have a flag for where am I pulling my model from, where am I pulling my inputs, and then where am I actually putting output, in this case, predictions. So I can read in my model file, then I loop through all the files and the inputs, do the predictions, write them out. Like I said, all the code for this is going to be online, so you can go deeper through there, and I'll add some extra stuff to figure out, so if you guys want to go even deeper into this stuff. And we can do the same thing there. And then make that. So cool. So there's the actual containers we're going to be using pulling our pipeline. Now let's actually build these data repositories. So Pachyderm, you have three ways to interact with it. Anybody from Kubernetes with kubectl with the command line has the same kind of concept there. There's also the language clients. So Go is the main client. That's what it's all written in. But there's other clients to interact with it. And that's probably your best bet for production systems. And there's also a dashboard, so a GUI thing, which is really nice to see your pipelines and go out with that. So let's check out that. So first thing we want to do is create our data repository for our training data. And so we can look at that. So here, now these data repositories, just like a Git repository, gives you a master branch. You can start now branching off if I want to test of certain, I don't know, feature extractions and stuff like that. Or we're going to stick with the master branch. And there's also 3 ways to get your data into Pachyderm. So it's all stored on cloud storage. In this case, I'm running Minikube, so it's a project that allows you to run Kubernetes on your local laptop. But all the major clouds, Amazon, Google, Azure, have those same Kubernetes clusters you can get. And you can pull it in from databases, you can pull from an API, so a URL, or you can just, what we're going to do, add files directly from your system. So here I have some training data. So really simple, just took the rating, the sugar, and the calories and put them down, so a whole bunch of different data points. So let's go in. Here we can just use the CLI again. We're going to add the file to our training, to the master branch. We want to add training. So cool, now we have that file in. Typing in front of people is amazing. So cool, so we can see our file, it's ready to go. Now let's do the same thing for our inputs. So repo inputs. And then we want to add our inputs. In this case, it's just going to be a simple structure. So here we want to predict if we had cereal with 8 grams of sugar and we had 120 calories, how would we predict that, or what would be going in there? So let's add that file. XCTL. So cool, now we're ready to actually look at the pipeline process. We have our training data, we have our inputs ready, and let's build those pipelines. So I have the JSON for that. Really simple, straightforward, just like what we said before. I have my name, I have my container that I'm using, the one we pushed, and we have a few commands to tell it. We also have a prioritization. So this isn't necessary, but what it does is allows us to do that scale out. So I can choose, do I want take up all the resources to do something? This is really nice for whether it be data processing or cleaning, that I have this large data that I want to break down, kind of a MapReduce style thing that's really easy to allow. And then I have my inputs. In this case, I want to do my training. Then I have the predicting. So same thing, have a name, my container, a few commands I'm passing in. The only difference here is we have 2 inputs. So what are the inputs I'm actually trying to predict, and then the model where I'm trying to find that. And there's this really cool glob. So anybody's familiar with glob, it allows you to really partition how you're going to give the directories or files or put them together. So cool, let's create those. So we can just do really simple, straightforward pipeline and training. So what that's going to do is going to set up and start watching the input, which in this case is training data. Once it finds new data and wants to process it, it'll spin up a job to start running that pipeline, and put everything through. So in this case, it's going to pull in the training data, train the model, and output into a model repository. So let's create pipeline. And the predict. So now this pipeline has a dependency, as we saw here, has a dependency on model. So it will wait for it to be finished training. In this case, it takes no time to train, and then pull in the new inputs and start predicting there. So we can see list repo. We can see it already created the model and prediction repositories. We're there to track this whole process, and it's tracking the commits, it tracks the history, everything you want to go through there. And so we'll look at the jobs. So we see, looks like, 2 jobs. So we have the first job is the actual training of the model. It output it to a model, and we see a commit ID. And the dashboard's much prettier to see this kind of stuff. But there's also a prediction job where it actually ran the prediction. So let's see what those look like. So we can get the model file from our model. So cool, here's what we outputted from our container, which is the B value, or y equals msplex b, is 81. And then we have our sugars and calories. So this is our actual model that we're outputting. And let's see what our prediction looks like. Prediction. Put. So cool, now we see our prediction for 8 grams of sugar, 120 calories. Looks like we're predicting a rating of around 37. So in reality, if you're actually building these pipelines, you would want to add some other things, like how much is my error for this model? Is it above the threshold? All this kind of stuff to actually build the pipeline, but give an idea of how you can really build these pipelines. And now that we have this built out, the power really comes in of I can just add data in. So I would add another input, put file into that inputs repository. And it's automatically going to detect that, kick off a job, start processing. Once again, though, this is kind of what we've seen in regular data science pipelines. So cool, we see another job kicked off, so it actually processed that. But now let's run through the entire pipeline. What if I have more data? Instead of parsing it and trying to train my model, deploy my model, now we can take it and just append. So here we see just a little extra training data. Let's append that to our training. XCL into our training, into the master branch. We want to append it to training CSV, and we'll append that data. So what this is going to do is the model pipeline is going to pick up that it has new data. It's going to be the same file appended. It's going to run back through, train it, add the new model. It's going to version that, so it's a new model. The predictions pipeline is going to read that there's new model available, and repredict everything. So cool, we see the jobs are going. It went through and repredicted. So this is really nice. Now I can just append data and run through my pipeline that I've already version controlled. I've already gone through code review. I know exactly how this pipeline is going to work. And that's where a lot of power. But let's look at, we can track our results, but what if this was bad data? Or what if I didn't want, it's not performing like I liked it to? Now let's revert back. So what I can do is see PacCTL. I can look at the commits history for our training repository. So cool, I see those two commits that we had, our initial training data, and then when we appended that data. Now all I have to do is delete the commit for the training repository. And we can look at our job history, and we see that it detected that there was dependencies of that training data throughout your entire pipeline, and it will roll back all of it back to your previous model. And so this is where a lot of that power comes in, and you can imagine building these bigger and bigger pipelines. That not only you have that power of declaratives, so it's all in JSON, it's all version controlled, tracked by everybody, but you can deploy these extremely fast, do the reverting, and get more of that software engineering feel to this data science problem. So with that, just some final things to go with and focus on is, remember, going forward, whether you're a huge machine learning shop or just somebody trying to build some models and think about that and give it customer impact, focus on your application. Really build those containerization is a huge part of this. Focus on your application. Look at these technologies for reproducibility and data versioning. We shouldn't have to be making copies anymore. And this is an important concept. And then finally, manageable deployment cycles. Anybody who's ever been on call realizes this is not a fun thing to try to figure out in the middle of the night why this is happening. And we shouldn't have to. We should adopt these CI/CD pipelines. We should do this. I mean, software engineering has been around for a while now. We have these frameworks and guidelines and best practices to make sure we can build these very manageable deployments and have these huge systems that are reliable. Well, data science is trying to go in the same direction. And I think Go is an amazing tool and powerful way we can start pushing that forward and building these applications that can really do some impacts. So with that, just want to say thank you. If you want to interact afterwards or talk anymore, I'm the only one with Sam Kreter as a name, so every handle is just Sam Kreter, which is super lucky. So look at GitHub, Twitter, anything, or come talk to me afterwards. If you want to argue about any topic in Go, I'm super enthusiastic about that, especially afterwards for dinner and drinks. So thank you.